All right, here we are. Actual day 2 of the module. Running through the whole thing again. I believe this is our first day of actually coding with using player controls. If I remember correctly. I don't know. I've already done this, but I just want to document everything and pick up little tidbits along the way that I may have left behind. So, oh no, right. This is the we are going to be doing the offsetting our camera so that way our camera follows us as we travel down the road. So we'll
Our
go
vehicle
ahead.
now can drive all the way down
Do
the
this. I
road. We have
can't
all
hear
these
shit.
obstacles that they can collide with. It has a whole bunch of physics applied to it, but our vehicle still moves a little bit fast, so we want to be able to change it, and we also want to be able to see it. To do that, we're going to use something called a variable. So, in our player controller script, right underneath this first curly brace, underneath player controller, we're going to create a new line by pressing enter, and then on that new line, we are going to create our very first variable. So, we're actually going to use this variable to be able to change this number here. So usually in code, it's pretty bad, especially when you have what's called a hard-coded number, because that means that if you ever need to change it, say we reuse speed for some reason ever again, we'd have to keep changing the number 20 versus we could just change the number in our variable. So what we're going to do is we're going to use the word float. Now float is a keyword that helps the computer know that we're creating a number with decimals in it. And then we're actually going to say what the name of this variable is. So we can call it speed, and we're going to use the equal sign here. Now it's very important, the equal sign to your code is very different than an equal sign when you're doing math in the real world. So this actually will assign our speed variable a value. So our speed will be set to whatever number we put next, and it will store that number whenever we need it. So because we are using decimals, we'll type a 5.0, so this is a decimal, and then we add a semicolon at the end, so that way we know we're at the end of this line. We are done with our statement. Now you can see that our IDE is pretty mad at us right now. There's this red underline, and it says that it doesn't understand what this 5.0 means. So actually what we need to do is we need to tell our program that this is a float, and so we add the f at the end. So now, as our computer tries to understand this line of code, now our computer knows that 5.0 is supposed to be a float specifically, so we add that f at the end. So now we have our speed variable. It's always carrying the number 5. If we ever need to, we can change it to be 10 or 20, whatever we want it to be. And so where we have our 20 in our update method, where we're transform.translating our object, we'll take out our 20 and just put speed. So now our code knows that we are multiplying by the value 5, even though we're using the word speed. So that's very helpful. So now, if we test our game, our vehicle should be moving a little slower. Not bad. So it's moving about 5 meters a second, and now it's just pushing those boxes along. Now, we want to actually be able to see this speed variable in Unity. So right now, our speed variable is a variable that belongs to this entire class. It's what we call a member variable. And right now, it can only be seen inside of methods inside of this class, and it can't be used outside of this class. Now, we can actually use the word private to denote the level of access that somebody has with our speed variable. The private keyword is what's called an access modifier. In fact, the public keyword is also an access modifier. So private can only be accessed within this class. In fact, this start and update method are both inherently private, so you don't actually need to type the word private. Versus the word public means that you can access, you can see, you can use this class in other places. So in fact, we want to be able to see and interact with our speed variable. So we will actually make this a public variable. So now that we've used the public keyword to modify its access, we should be able to see it in Unity. Now, a cool thing that happens when we go into Unity, if we click on our vehicle in the hierarchy, in the inspector, underneath the player controller script, you can actually see our speed variable now because it's public. And we can actually change the values however we want just by typing in any number. So I'll set this to 15, and then we'll press play. And you should see the car zip down the road. And a cool thing I can do, if I left click and drag on the speed variable on the word itself, if I drag it to the left, it actually brings it negative. You can see it racing down the runway. Then if I bring it up, it goes up. And so this is a cool way to see exactly how fast you really want this vehicle to go. And then 5 is kind of a good speed. Now let's make it to like 11 or so, 12, cool. Now when we stop playing, oh, our speed variable reset to 15. Well, if you remember, when we enter play mode, if we edit values, it'll reset those values when we exit to the way that it started when we were in our scene. So it actually set it back to 15. So we'll just bring this to like 10 for now, and then we'll save. A fun little tip for when you're programming, something that people commonly say whenever they create their variable, but then also assign it a value at the same time. This is called initializing a variable. And so we initialize the speed variable to be at 5.0 for its speed. So what you're going to do is you're going to create your very first variable so we can store the speed that we want our vehicle to move. Make sure that you use the keyword public so that way we can see this variable outside of this class and use it. Use the keyword float, that way we know that our speed variable is a number that uses decimals. We can choose what we want to name our variable, so we'll name it speed, and then we use the equal sign to assign or to set our speed to be 5, and then make sure if you use the .0 just to add an F at the end, so that way our program knows that this is a decimal number, and then in your update method, change the 20 to speed and test your game. And then while your game's playing, if you select the vehicle and then you go into play mode, you can actually left click on the speed under the player controller and drag it, and you can change the numbers by scrolling side to side. Now it's your turn.
Save that. Shia. Yep. And rigid body mesh renderer. Easy as shit.
We've added a variable to our vehicle. So if you select the vehicle in the inspector, you can see that speed variable under the script. Now when we press play, we can actually click on that speed variable, drag it, and we can control the speed. So we've got some good control, but our camera is still locked in the same place. So we want to make it so we can actually follow the player as they move back and forth. To do that, we'll create a new script. So underneath your assets folder in your project window, if you go down to scripts, right-click on scripts, create a new C# script. We're going to name the script follow player because this will attach to our main camera, and the behavior will be that the camera will follow the player. Make sure you name it correctly with the capital F and the capital P with no spaces, and then we're going to left-click on follow player and drag it onto our main camera. Now, if we click on our main camera in our hierarchy, you can see the follow player script has been applied as a component. So now we're going to open our follow player script by double-clicking on it. So now our script has opened in our IDE, and what we're going to do is we're going to use public variables, but in a very different way this time. So what we can do is we can actually get a public variable, and what we're going to do is we're actually going to use a class or a type, in this case, a game object. And so, like I said before, things like our obstacle or our vehicle are game objects in our project. And so actually, we can get references directly to our different game objects like our player. If we check in Unity, you can see now in our follow player script, it's added this line of code. If we select our main camera in the hierarchy, you can see that
Is
the
the
follow
washing
player
machine
script
jamming?
has this player variable,
What's that noise?
and it's looking for a reference to a game object now. And so in fact, we can actually
Is it
left
just
click
working
and drag
fine?
our
It
vehicle
sounds
from
weird
our
while I have my
hierarchy
headphones on.
into that box, and now our player variable is tied to our vehicle. This is one way that you can get a reference to an object in the scene for another object to use. In this case, our main camera to use the vehicle. So variables can be used in really powerful ways, not just to store numbers, but to store references to other things that already exist in our game. Now what we're going
That's
to do
pretty
is
fire.
we can
This is
do a
how I'm gonna
really
make the health
interesting
bar
thing
attached to
where we can
a.
actually get the transform. So
This
this
is what he
gets us
does
the
all day.
current transform component of the game object that this script is applied to, in this case, our camera. So we get our camera's transform, and we can actually just get its position overall. And so this will give us the X, the Y, and the Z of where our camera currently is. Now, we're going to use that equal sign, that assignment operator. We are going to set our camera's position. Now that we have a reference to our player, we can actually use player. The player also has a transform component, and we can actually get that position from the player's transform component. And then if we semicolon to end our statement here and make sure we save, so now our camera's position will be set to the player's current position. So now, if I press play and you watch in the scene view, watch our camera and our camera should be set to the position of our vehicle. There you go. Kind of works. It's underneath the car, which is close enough to what we want for now, so we can watch it as it drives down the road, runs into the different boxes. Cool little perspective. So what you're going to do is, in Unity, make sure you go to your project window, right-click on Scripts. You're going to create a new script, a C# script. You're going to name it Follow Player, capital F, no space, capital P. And then you can left-click and drag it onto your main camera.
I want to love you, pretty young thing. Nope. Loving gal, and I'll take you there. Yes, I will now. Better do bit bit. Oh crap. Better do bit bit. Dude, I did it a fucking. Why the hell do I keep? Yeah, I'm out of it today. I think I made the exact same error twice. And we need to add reference to game object. That is going to be public game object is player. And we are just going to transform dot position equals player dot transform dot position. Easy hell. And what this is going to do is just make our main camera follow our player. Right now it's going to actually make our main camera be in the exact same spot as our player. But that's alright by now. Did I not get that on there or something? I did not. And we're just going to attach the player game object to this camera, and now we are under the vehicle. Yes. Easy peasy. Yeah.
Our camera is now positioned. Unfortunately, it positions underneath the vehicle, which is an interesting perspective, but not exactly what we're looking for. We actually want to create the same effect that we have in our camera here in our preview. So that way we're following behind the player instead of underneath the vehicle. So we'll change that perspective using some of our code. And then what we're going to do is where we're actually setting our camera's position to our player's position, this is actually where we're going to add to our player's position so that we can offset our camera above and behind our player. Fortunately, we already did some of this work before. So luckily, the player vehicle is at 0, 0, 0. And then what we did with our camera is we actually put it at 5 on the Y and -7 on the Z, so it went up and then it went behind our player here. So we can actually use those values to be able to reposition our camera behind the player when the game starts. So using our update method, since we're constantly keeping track of the player's position, we want to add, in this case, we just use a plus sign like you would on a calculator, and then we should add, I
Bear,
believe it was
can you
0,
please stop?
and up 5 meters, and then back 7 meters, so -7. So that doesn't seem to work. So let's see. I believe the problem is, so in fact, our player's position is giving us a vector 3. And here, although this would make sense in our heads, this doesn't make sense to our computer at all. Our program is trying to add some statement that it doesn't exist, and it's trying to add it into our vector 3. So what we actually need to do is we need to add two vector 3s together. So we actually need to create a new vector 3, and we're going to use the keyword new because we're actually creating a new vector 3 instance. We're not creating a vector 3 variable that we're storing or saving. Since this is just temporary, we use new vector 3. And so now this will actually create a new vector 3 just for this line of code.
Both these
That'll have the
cats are
values
just
of
at
0
the
on the
front
x,
door, like going
5 in the
crazy.
y, and -7 on the z. Last but not least, we're going to add a comment to our code. So we're going to say offset the camera
Offset.
behind the player by adding to the player's
Position.
position. Now we make sure we save. So now if we test our game, we should see that our camera is just following the vehicle. Awesome. So now we have a much better view of where we're driving and where we're going. So what you're going to do is in your camera's position, where you set it to be the player's position, you're just going to add a new vector 3 with the values of 0, 5, and -7. Now it's your turn.
I want to love you. What the hell? Oh, was I in the freaking... What script was I in? Follow player. Plus. This is the fixed. Hello, kitty cat. Get off my computer, please. And listen to this guy. Meow.
Now our camera is positioned perfectly behind our vehicle as it drives down the scene. What we're going to do is we're just going to clean up our code just a little bit to make it easier to understand. In our follow player script, I mentioned that it's really bad to have hard-coded values. So we're actually going to take this vector 3 we've created and create a variable for it. So this one will make a private variable, so it can only be used
got a
inside
bunch
of this
of
class.
sleep. That's why he's
So
doing
I'm just going to use the keyword private here so you can see how it's used. Very similar to a public variable. And for this, because we're making a vector 3, we need to make this variable a type of vector 3, and we'll call it the offset. Now we set this variable to be this value here. So in fact, we can just cut
What'd you say?
by Control or Command X with the code highlighted,
Brother,
and then we go to where we had the offset, and we paste with Control or Command V. So now our offset vector variable is being set to that new vector that we made before with our offset position already added to it. So now, in our update method, we can just add where we removed that bit of code, the word offset, and because offset is a vector 3 being added onto a vector 3, then we can set our position properly. Make sure you save, go back into Unity, and press play, and you should see that nothing has changed, which is exactly what we wanted to happen. So what you're going to do is in your follow player script, you're going to create some of variables of your own. You're going to make a private vector 3 variable called offset, and you're going to initialize it by assigning it that new vector 3 offset that we had created down in our update method. And then you're going to remove that new vector 3 line and just replace it with the word offset. So that way, it's always just using the offset variable, and if we ever need to change our offset numbers, we can just do that here at the top of our code. And then just make sure that you press play and test to see that it's working exactly like it should. Now it's your turn.
What was that, my love? What, being pains in the butt about wanting to be outside? They're like, we can see, dog. He's like, oh my god. Oh my, why is... What happened? Oh. Greg is it, Greg is it, Greg is it. You don't know, no, man. Wee. What? Why is it doing this? This is fixed update. You know, late update. There we go. There we go. There you go. There you go. There you go. Doggy loves it. He's like,
Okay, now that we have our camera following our vehicle properly, you might notice that there's a weird effect happening with the vehicle itself where it's kind of stuttering back and forth. And so we can make one small change to our.
alright, this is what I already did. Edit player mode tint color. Alright, well. No. I ain't messing with that. Alright, great. So finish that. Now we are going to actually add player controls. This I'm going to actually do the regular way because I don't care.
Our vehicle drives down the scene now, and when we press play, we have this nice tint to show us that we're in play mode, and we have our camera following, but right now, we still can't really control our vehicle. It just drives all the way down the road, just running all these obstacles over, pushing them off, and then eventually it gets to the end of the road, and then it just falls straight off. That's just because there's not an end there. But we need to be able to control this vehicle's movement. So first we need to be able to move our vehicle so that it avoids the obstacles. If we open our player controller script, we're going to need a way to control our vehicle to move left or right. So we should probably just use a variable to do that since we know it's probably pretty bad to just use a random number. So good to think ahead in general. We're going to make this a public variable so that we can control it just like we did with the speed. It will also be a float because we'll be using decimal points. And then we're just going to call it turn, lowercase t, capital S for speed. So you can see here turn speed has different capitalization. So this is a very standard, what is called a naming convention when you're programming. So for variables, we often use lowercase letters like speed, turn speed, even transform is a variable to be able to very easily see when we're using a class or when we're using an object, when we're using methods, or when we're just using variables. Now we want to be able to move our vehicle left or right, so we'll do something similar to what we did with our transform.translate. Instead of a vector 3 forward, we can actually use, there's a whole bunch of other options for vector 3, so we can actually use like right. So this will move our vehicle in the right direction. Again, we're going to multiply by time dot delta time because we want to be able to update this position over time instead of once every frame. And then we multiply by that handy turn speed variable that we made before. So now in our game, if we take a look down at our game view and we select our vehicle so we can see the values, if we press play, nothing's happening. Well, that's actually because we're multiplying by a 0. So actually, if we click on turn speed and drag it to the right, it'll actually start turning right if it's positive. If we go to the left, it'll start going to the left because the value's negative. So easy way to see how we can move our vehicle left or right. Now that's great, but we'll need to be able to also control it as well. But first, what you're going to do, in your player controller script, create your own turn speed variable.
Turn speed. Back to player controller. We are public floating. Spirit turns. Does he just not declare it? Does he, or does he speed? Oh. Right. Not at this exact moment. I will be though. Crackers and crackers and crackers and crackers and crackers and cheese. Player. Bet. Beacon Skybrip.
Our player can now drive down the road and we can change the speed of its movement. We can even change the speed of its turn. However, if our player is actually playing the game, we don't want to be able to fly off the road, for one, but also, if our player is using like a joystick or something, we can't just be dragging this variable around. We can't do this for a single player, like it's magic behind the scenes. So we're going to create some actual magic so that the player can actually control their own movement. A very helpful thing to know before we get into programming this is understanding that Unity does a lot of things that make our lives a lot easier. So, in fact, if you go to the top left under Edit, or if you're on Mac under Unity, if you go down to Project Settings and you click on that, there's all these options for project settings, but what we really care about is actually our input. So this is actually our input manager in Unity, and they've helpfully already created a way where when you do something, it's already mapped to be able to change that value. So if you left click on the drop down on axes, you can see there's different ones, like there's actually fire button, so you can actually press like the left control button to fire something, or a second option, left alt, left shift. There's a jump, which is the space bar. You can take a look at all these different options, but what we're looking for specifically are actually these horizontal and vertical axes. And so this is actually how Unity knows if we want it to go left or if we want it to go right. Using these horizontal axes, we can actually see those values change and how they change. You can see that there's inputs for the left arrow key to go negative or the right arrow key to go positive. There's also alternative buttons for using the A key to go negative or the D key to go positive, and it's called the horizontal axis. Knowing this, we can do something really easy to be able to control the player's movement. In our player controller class, first we're going to create a public variable so we can actually watch and see what it's doing, and this will be a float again, and we'll call this horizontal input because this is actually the input that we'll be tracking on our horizontal axis, left or right. And then what we need to do is we actually need to set this variable, which we'll do inside of our code. So we'll actually do this in our update method. So we use our horizontal input, we call our variable, and then we use the equal sign. So we're going to assign this variable some value. And now if you remember that input manager, so there's actually a class and a method that we can call just for that input manager. So if we type capital INPUT, so this is our input manager, it's called input. So now that we have our input manager class, if we type dot, and then we were looking for that axis before, so we can actually use our getAxis method. So this will give us the values for when we press the left or right key on that axis, but we also need to tell it which axis we want to use, and in this case it's asking for the name of our axis, specifically a string. Now a string is a way for your computer or program to create a word that is literally interpreted by the computer and easily understandable for us. So, for example, if I in here actually type in a double quote, you can see it actually auto-completes a double quote for me at the end. So this is creating a string literal inside of these quotes. So it'll literally interpret anything that I put in. I could literally say hello world, which is very helpful if I'm trying to, for example, print something, or I need the program to tell me an error that's happening or something like that. Using string literals can be helpful in that sense. For this, we actually type in the word horizontal, because in Unity, in our input manager, the name of our horizontal axis is just horizontal. So now we're getting the input for whenever a player presses the left or right key. And then last but not least, we need to actually go into our translate and multiply this by our horizontal input. So now if you make sure you save, we can close out of our project settings. And let's make sure we select that vehicle so we can actually see what's happening on the horizontal input. Our turn speed is set to 0, so we know that's not going to work. So we'll set it to 1 for now. And then if we press play, so we should see if we press the left arrow key, it slowly moves to the left. If we press the right key, it slowly moves to the right. And we can use the A key too if we want to use the other key. It'll move to the left. If we use our D key,
Cool.
it will slowly move.
There's another one of these. Mm. Input dot get axis string literal. And then also get the speed to horizontal input. I need, what is it, in window. How do I get to the input manager again? UI toolkit components. Nope. Window. What was it? Where's this shit at?
We can't do this for a single player, like it's magic behind the scenes. So we're going to create some actual magic so that the player
Jesus
can actually
Christ,
control
Oliver.
their own movement. A very helpful thing to know before we get into programming this is understanding that Unity does a lot of things that make our lives a lot easier. So, in fact, if you go to the top left under Edit, or if you're on Mac under Unity, if you go down to Project Settings and you click on that,
Project settings. Input manager. This is what we've used so far. Wait. Yeah, there it goes. Fire. Oh my god, Oliver. Money. Money in a bank. Why does this not... This guy. All day I'm at work and this is what I got. It's just so, like, insane. Can you shut that back door again a minute and shut it? I know it's gonna be 10 times more annoying, but it's cold. It's cold outside. Take control of the speed. So this is gonna be forward input. Same exact thing. Sweet.
our vehicle can now move to the left or the right. Looks a little weird, but we'll fix that later. The problem is we keep moving forward, and I want to be able to control that too, just to make it a little bit more interactive. So if we take a look at our input manager again, in the top left, if you click Edit or Unity, go to Project Settings, select the input option, and then make sure to expand the axes. In this case, I'll collapse our horizontal axis. You can see the vertical axis here with the name vertical and uses down for negative, up for positive. So we can do the same thing that we did with our horizontal input and do that with our vertical input. In our player controller script, we're going to create another variable. We'll make it public as well so we can see it. We'll make it a float because we need decimals, and we'll call this forward input to control our movement forwards or backwards. Similar to what we did with our horizontal input, we'll create a new line. We use our forward input, and we're going to set this to our input manager. .getAxis, use quotes to create a string literal, and then we use vertical. And then we will change in our translate method for moving forward.
Although I spelled them both wrong.
We'll just multiply by our vertical input. Our forward input, I should say. So now in Unity, if we close the project settings and then we press play, we should see hopefully our vehicle doesn't move at all. Cool. And then if I press the forward arrow, it moves forward. If I press the backwards arrow, it moves backwards. Same thing with W, moves forwards. S moves backwards. And then I can even move forwards and move to the left at the same time. I can move to the right with the arrow key. I can even go backwards. Make it really challenging for myself. Can't see the boxes.
Yeah, that one's getting cooked. That was like legitimately the exact same thing as the last video.
We have full control over our vehicle now. It's not just driving off down the road. But now we have some weird stuff happening. So when we press the left arrow key, we slide to the left. And if we press the right arrow key, we slide to the right. To visualize again what we're trying to do, I'm going to go into my top-down view by clicking the green Y arrow in my scene view, and now I'm very high up in the sky. If I select my vehicle in my hierarchy and I press F while my mouse is hovering over the scene, we focus back into the vehicle. Now I'm actually going to select my rotate tool. So let's see what's changing actually when we click on this circle here. If we drag it to the left, you can see in the inspector underneath transform, the Y rotation is actually the thing that's moving. So that's probably what we'll want to change in our code. In our player controller class, we already have this bit of code here where we're moving left or right. Let's see, well, if we are using our vehicle's transform, then we'll need that transform component. Now let's see, luckily, because my IDE suggests different methods that I can use, well, there's this one method called rotate, so it'll actually rotate it at an angle. Well, let's just see what it does. So if I click on the rotate method, and then I type an open parentheses, it suggests different things. So it wants a vector 3, Eulers, an axis, and a float angle. That one seems pretty useful. Well, we know that the axis is that y-axis, that vector 3 up. So actually, vector 3 dot up. And then it wants the angle. Well, we kind of already calculate an angle here because of our turn speed. Let's just see what it does. So if we select our time all the way down to our input in our vector 3.right translate, if we cut that out with Control or Command X, in our rotate method, after the comma, make sure to paste that entire line of code in there. We're going to put the semicolon to close that statement, and then we just delete our translate there for vector 3 right. Now if we save, we'll see if that works, if that was what we're looking for. Now when I press play, if we watch the vehicle in our game, as I drive forward, I'm turning left and I'm turning right ever so slowly, but I'm turning, so that looks pretty good. So what we'll actually do is, if we select our vehicle in the hierarchy, we'll turn the turn speed up to like 25. We'll see what happens. We're just testing anyways. Now we'll play again. There you go. Now it looks like our car is really driving down the road. That's awesome. Look at it go. Just driving all around, avoiding all those obstacles. One very cool thing to note, so in fact, if I actually go in my scene view, and I'm going to keep play on here just so we can kind of see what's happening. So you can see in our game, as I move forward, it always knows what direction it's moving forward. Now, we've been moving all of our objects in our scene, if we select our move tool, based on the global position of things. So we're always doing it based on 0, 0. Our Z arrow will always go positive in the Z. Same thing with our X arrow and our Y arrow. But at the top left, next to all of our tools, you'll notice this button here that says global. In fact, if we actually click on global, we can set this to local. Now, let me get a better angle so you can kind of see what's happening. So as I turn the vehicle, nope, make sure you have the game selected. As I turn the vehicle, you can see that the Z is changing, and it's always pointing in that forward direction. But then if I switch this toggle back to global, you can see that the Z flips back to the positive Z direction of our world. So when you're trying to position things in your world, it's helpful to have that toggle set to global. But then when you're testing things, like if you want to make sure that your object is facing the right direction, you can toggle it to local, and then you can see which way your object is pointing while you're trying to interact with it. So that's very handy. Very helpful tip in case you ever need it. So what you're going to do is in your player controllers.
Move the vehicle forward. Turn the vehicle. Rotate. Okay. Why is that not working? Oh, this is not working because this right here. $25. Get a fuck offy. Fucking back up. Back up. Fucking Crash Bandicoot. What is this? Clean your hierarchy in code. They want to set them here? Okay. You should look at all variables. Bada bing, bada boom, bada done, man. Okay, well, I fucked this up somehow. Oh, I guess 45. Let's go 15. Bada bing, bada boom is done. Fuck these guys. A fucking great driver to knock any of them over. Swaggy. Watch this. Watch me learn how to fly right quick. Way to go! Alright. I should be able to fly upward, right? Yeah, I don't know. Back to this challenge. Challenge 1. Mentally challenged 1. I don't like that the extra is no longer in here. Why is the extra? It's probably because it was stumping some people. Make the plane propeller. Want even more challenges. Oh, they were down here. Okay, well, I'm gonna call it here just because I want to do the challenges. I didn't realize that the extra challenges were actually at the bottom of the challenges, so I'll actually do that going forward and into the weekend. Um, Tomorrow I got super busy, so I'd like to game a bit. Um, Finish the actual unit one, and now we're just going to challenges. After challenges, we could go ahead and do the bonus tutorials for the challenges as well, and we'll kind of take it from there. But there you go, day two.